You know, every single day we are just swimming in an absolute ocean of data. I'm talking sports stats, movie ratings, economic reports. It's just everywhere. But how in the world do you make sense of it all? Well, the secret isn't just having the data, it's understanding the different types of data you're looking at. And that is exactly what we're going to break down today.
So let me just ask you this straight up. If I handed you two different lists of information, would you know how to tell them apart? This is way more than just a trivia question, you know? It's a fundamental skill for really understanding the world. And trust me, by the end of this, you are going to be a pro at it.
Okay, so at the highest level, it all starts right here. It's actually pretty simple. Every single piece of data you'll ever see falls into one of two major families. On one side, you've got qualitative data. Just think quality. That's all about descriptions. And on the other, you've got quantitative data. Think quantity, which is all about the numbers.
Getting this first distinction right, honestly, it's the key that unlocks everything else. So let's zoom in and really get to know each of these types.
First up, we've got qualitative data. This is the what kind data. It's descriptive, right? It's all about sorting things into categories. Think about it. Your college major, the city you were born in, your eye color. These are all attributes or labels. They describe a quality about you, but they aren't numbers you can just add up.
And then on the flip side, we have quantitative data. This is your how much or how many data. These are the things you can actually measure or count. Your age in years, the weight of a package, the temperature outside. I mean, if it's a number that represents a count or some kind of measurement, you're looking at quantitative data. Simple as that.
And what's really cool is that these two types, they often live side by side. Take this chart on sports-related head injuries. The list of sports, basketball, football, soccer, that's qualitative data. They're just labels. But the number of injuries for each sport, that's a count, so it's quantitative. See? They work together to tell a much bigger, more complete story.
Okay, so we split all data into two big families. Now, let's get a little more specific. We're going to start with the qualitative side and look at the two subtypes of all this descriptive data.
So the simplest level of measurement is called nominal. A good way to remember it is nominal sounds like name. This is data that you can put into categories, and this is key, those categories have no natural order or ranking. You're basically just putting things into labeled buckets. And because there's no real numerical value, you can't do any math on them.
Movie genres are a perfect example of nominal data. We can group movies into action, comedy, drama, and so on. But is drama somehow mathematically better or greater than adventure? Of course not. It just doesn't make sense. There's no logical way to rank these categories. Sure, you might have a favorite, but that's just your opinion, not some kind of mathematical order.
All right, the next level up is ordinal data. Just think ordinal sounds like order. Here, the order of the categories finally matters. You can actually rank the data from top to bottom. But, and you really got to remember this part, the actual distance between those ranks isn't meaningful or even measurable. It's why you can't, say, calculate a meaningful average of a top 5 list.
Take a look at this list of jobs with the most projected growth. This is classic ordinal data. We know for a fact that the job at number 1 is projected to have more growth than the job at number 2. The rank is meaningful. But here's the catch. Just by looking at this list, we have no idea how much more. Is the gap between number 1 and 2 the same as the gap between 4 and 5? We just can't tell.
All right, let's switch gears and head back over to the quantitative side of the family tree. This is where things get really fun, because this is where we can start doing some actual math. The differences between our data points are about to become very meaningful.
So, inside of quantitative data, there are two more levels, interval and ratio. Now, they're super similar. Both have an order and both have meaningful differences between values. But they are separated by one incredibly important idea. What does the number 0 actually mean?
So first, let's talk interval. With interval data, 0 is just another point on the scale. It does not mean the absence of the thing you're measuring. The classic example is always temperature. I mean, think about it. 0 degrees Celsius doesn't mean there's no heat at all, right? It's just a position on the thermometer. Or think about years on a calendar, like when the New York Yankees won the World Series. This is interval data. We can absolutely calculate the difference. The gap between their 1927 and 1932 wins is 5 years. That's meaningful. But the year 0, well, that doesn't mean time didn't exist before then. It's just a reference point. And that's why you can't say the year 2000 is twice as late as the year 1000. That kind of ratio is totally meaningless here.
And that finally brings us to ratio data. What's the key difference? For ratio data, 0 is not just some placeholder on a line. 0 means 0. It is a true absolute 0 that means a complete absence of whatever you're measuring.
These American League home run totals, this is a perfect example of ratio data. A team can score 0 home runs, and that means exactly what it sounds like. They hit no home runs at all. And because we have that true 0, we can now make meaningful ratios. A team with 80 home runs has hit literally twice as many as a team with 40. The math just works perfectly.
So, we've gone all the way from simple labels to really powerful numbers. Now let's put it all together into a simple framework. Think of it as your own personal decoder ring for any data you ever run into.
And here it is. This is the ultimate cheat sheet. Notice how each level builds on the one right before it? It gains a new yes as you go right down the list. So to figure out what kind of data you're looking at, just ask these simple questions. Can you put it in categories? Can you arrange it in a meaningful order? Can you subtract the values? And finally, can you make a meaningful ratio, like saying one is a multiple of another? Just walk right down that checklist.
And there you have it. You now have the 4 fundamental levels for classifying any kind of data. You've gone from looking at a confusing sea of information to having a real framework to organize and understand it all. So my question to you is, with this new knowledge, what data in your own life, at work, in the news, even your hobbies, what are you going to look at differently now?